Alright, we're going to continue filling out our yellow MTT. This is going to be box 6. We're going to be looking at solving with exponents and then simplifying. So the first problem is 3x squared. You're going to go ahead and substitute in the 4 for the x, and then we're going to follow PEMDAS. So we're going to do exponents first. So 4 squared is going to be 16, and 16 times 3 is 48. Now we're going to look to see what happens when the parentheses are put around the 3 and the x. So we're going to go ahead and substitute in 3 times 4. And now we're going to do PEMDAS, which says do the parentheses first, which is 12 squared, which is 144. So you'll notice that when the exponent is just on the variable, you get one answer. And then when the exponent affects everything inside the parentheses, you get a different answer. But both times we follow PEMDAS. Alright, let's try another one. We're going to go ahead and substitute in the 4. So it's 3 plus 4 squared. Now we're going to follow PEMDAS, so it's going to be 7 squared, and it's 49. The next one, 3 times 4 squared. Notice that there's no parentheses around the 3x, so the exponent only affects the 4, plus 3 cubed. So we're going to do 3 times 16 plus 27, which is 3 times 3 times 3. Now, forgot this is a negative 3. Okay, so with it being a negative, we need to put a negative in there, and that's going to be a negative 27. This is going to be 48 plus negative 27, which is going to be 21. All right, now we're going to start talking about prime factorization, so let's review what a prime number is. First of all, we're going to remember that 0 and 1 are neither prime nor composite. They are neither one. So then we're going to take the first 20 numbers and divide them into prime and composite. Remember that prime, like 2, is a number that you can only get by multiplying itself times 1. So 3 is also prime. 4 is composite because you can get 4 by doing 4 times 1 and 2 times 2. 5 is prime. 5 times 1. 6 is composite. 6 times 1 and 2 times 3. 7 is prime. 7 times 1. 8 is composite. 1 times 8, 2 times 4. 9 is composite because you can do 1 times 9, 3 times 3. Go ahead and pause the video and finish filling out numbers 1 through 20, and then go back and start it again and see if you were right. So 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, and 20. So now you know the first 20 numbers, whether they're prime or composite. Now we're going to review how to do prime factorization. There's 2 ways that you can do it. You choose the way that you like best, but include both in your notes. The first is the factor tree. So we're going to break down the factor tree. We're going to break down 24, and we're going to do 6 times 4, 2 times 3, 2 times 2. As soon as I have prime numbers, I'm ready to start my answer. We can also find our prime factorization with the upside down cake. So we can start with 2. This is 12. 2 again, this is 6. 2 again, this is 3. And you'll notice that we have 3 goes into 3 one time, and there are the same exact prime factors. Now we're going to look at the variables. We need to write out the variables as a times a because it's a squared, and b times b times b. And then what we're going to do is we're going to take all of the factors and put them together. We're going to do it from least to greatest. So our answer for this would be 2 times 2 times 2 times 3 times a times b times b times b. There's no exponents because there are variables. All right, let's do the next one. The next one we're going to need to break down negative 32 first, and then we're going to break down our variables a squared, b cubed, and c. And actually, you can do your variables first. That's the easiest. A times A, and B times B times B times C. Now this is a negative, which means our very first thing we're going to do is take out our -1 and 32. And then we're going to break down 32, 8, and 4. Break down 8, 4, and 2. Break down 4, 2, and 2. Break down 4, 2, and 2. You want to circle your prime factors, and then you're going to put them in order. So it's going to be -1 times 2 times 2 times 2 times 2 times 2 times A times A times B times B times B times C. Always double check to make sure that you've got all of your factors in, and again, we're going from least to greatest. You can also do 32, -32 using your upside down cake. So this would be -1, which would be 32. Take out a 2, which would be 16. Take out a 2, which would be 8. Take out a 2, which would be 4. Take out a 2, which would be 2. Take out a 2, which would be 1. And you notice that you get the same exact factors. So our answer here has no exponents because we're using variables. Now we're going to just review quickly how to do GCF, which is greatest common factor. So we're going to use the upside down cake method, which is the easiest. We're going to take out a 2 because they're both even. So this is 15 and this is 12. We're going to take out a 3. This is 5 and this is 6. And now there's no number that will come out of 5 and 6. So our greatest common factor for these two numbers, greatest common factor, is going to be 2 times 3, so the GCF is going to be 6. Greatest common factor, which again we used a little bit earlier when we were factoring the first variable terms. Okay, now let's do one. Actually, let me also remind you too that we can find least common multiple, and the least common multiple is taking all of these numbers, see the L that I just drew, and multiplying them together. So this would be 6 times 30, so the least common multiple would be 180. So least common multiple. So you can do the same work and get 2 of the answers. So now we're going to do greatest common factor and least common multiple on this one. So we're going to start out, 13 goes into all 3 of these numbers. 13 goes into 13 once, 13 goes into 39 3 times, and 13 goes into 52 4 times. Now, for greatest common factor, there is no number that will go into 1, 3, or 4, so my greatest common factor is 13. Greatest common factor is 13. There is no number that will go into 1, 3, or 4, and there is no number that will go into just 2 of the numbers, so I'm going to go ahead and do my least common multiple, and that is going to be 166. So least common multiple is 166. All right, now let's see what we do with greatest common factor with variables. The first thing we're going to do is take our variables and line them up. So B is in my first term, 14B, and my second term has 3 B's. What I'm going to do is I'm going to see how many B's they have in common, and that drops down into my answer. Now I'm going to do greatest common factor. So the greatest common factor for 14 and 56 is 7. 7 will go into 14 2 times, and 7 goes into 56 8 times. Now I can take out another 2. 2 will go into 2 1 time. 2 will go into 8 4 times. And nothing will go, the only number that goes into 1 and 4 is 1, so you're done. This is going to be your GCF. So our GCF for our numbers is 14, and we put that together with our variable, and we have 14B. All right, let's try 30 and 24. We're going to do our variables first. So A times A times A is A cubed times B squared. That's my first one. And then I'm going to do A times A, and I'm going to line up the variables. So I see that I have 1A in common. I have a second a in common, so I have a squared in common, and I have a b, so those are part of my answer. Now I'm going to do 2 goes into 30 15 times and 12. 3 goes into 15, 5, and 4. 1 is the only number that goes into 5 and 4, so you're done. 1, you're done. So my greatest common factor is going to be 6. Greatest common factor for my numbers is 6, so my answer is 6a squared b. That's it.